Well, thanks for joining us for today's webinar on security visualization. We're going to be talking about using interactive data visualization and predictive modeling to find needles in the haystack with cybersecurity data. First, I'm your host. My name is Doug Cogswell. I'm the President and CEO of Advisor Solutions. We've been in the business intelligence sector for about 15 years and have extensive data analytics experience with over 10 years of doing work in cybersecurity. Our clients include Fortune 100 companies. You'll see a case study from one of them today. Large government organizations, the U.S. military, and two of the top SEM vendors. So just a bit of background. We are a spin-off from Lucent AT&T Bell Labs here in the Chicago area. We were developed to help manage large amounts of log files from switching and telecommunication systems and give people the ability to see overall patterns but then drill down to detail to take action against logs, which is exactly the same thing we're doing in cybersecurity. We offer a low-cost visual front end to complex data systems. We blend, prep, synthesize data from all kinds of data systems. We load it into an in-memory data mart, which gives us our interaction and our ability to quickly slice across different tables. We've embedded no-coding predictive analytics into an end-user tool targeted at people who don't have degrees in stats so they can explore and do things like we're going to talk about today. So as we get into security visualization, this is a topic that runs across smaller firms all the way up to top-tier, best-of-breed. When we get into some of the smaller firms, the problems are multiple. You know, in general, threat teams and vulnerability teams often don't talk to each other. There's multiple separate collection systems that create hundreds of pages of reports each day. So what we often see is analysts pull the data out and try to cross-rough it in Excel, which is doable but hard, and we would call that actually the cycle of pain. And it lacks context. You have to prioritize but only investigate some things, which are usually the high priority threats, when in reality there could be clusters of lower priority events that together make a difference. And we're going to see this a bit later in our demo. So what ends up happening is the teams put out fires versus taking a more strategic approach, and they get distracted by all the noise in this data and don't find the needle in the haystack that may be the key thing, the next major threat they need to examine and take action on. Gartner Group supports that set of assumptions and observations. They say analyzing large amounts of data to find interesting security events such as undetected breaches or rogue users is a desired output for buyers. And they add visualization of that data will greatly affect the adoption of the technology. So they say it presents an opportunity for security providers to partner with proven large data visualization technologies to better increase the adoption of their security analytics platforms. So just to summarize at this point, and there's all these events, these threats coming in. Some of them are detectable by rules-based engines. Some of them are pretty obvious. Some of them are not. And the ability to look at the data, apply human pattern recognition to it, can be extremely helpful at prioritizing and calling out the wheat from the chaff, finding the needle in the haystack. So let's dive into a case study. One of our clients, a Fortune 100 company, and this is their story. They have multiple data sources, as many of you do. Intrusion detection, source fire, there are others, but that's a clear leading player. Firewall, Palo Alto and Sonic Wall. Virus scan and endpoint protection, Symantec. There's other versions of these, but these all create tremendous amounts of data. And the bigger players generally have correlation systems that load all this data, such as Hewlett-Packard Enterprise Security Management Group, ArcSight Logger, and the like, Splunk, and there are others. And these are generally rules-based, so there's some kind of a known trigger. It aggregates, correlates, identifies issues, and sends the case investigation and also a response. So that's typically what's going on. Where our client would say security visualization fits in is in front of all of this. So to the extent the correlation systems are aimed around rules-based detection systems, algorithms, and approaches, security visualization is really the hunt for the unknown and the unexpected threats, which may in fact be the most serious because the attackers are aware of the rules and the detection systems, and they're trying to come in and unanticipated ways to get around them. So the ability to at least spot them and be able to dive in and take them to case investigation to explore them further is really important. And that's where a security visualization fits in. Also, we don't just load from the correlation systems. Often we'll go back and we'll want to pull specific data from the virus scan or the firewall or the intrusion detection system. And in fact, in our demo, we're going to look at doing just that with a SourceFire data set. So let's take a little bit of a dive into security visualization. Just to start, I've watched some of the webinars and we've heard a lot of people talk. Most people think of visualization and security as presentation output. So the team, does some work, they found some stuff, and they want to show management what's going on. So they use a visualization tool and pop up some charts and come in with a dashboard or a report or whatever and show management. Our clients speaking here, they think of this as totally different. They mean presenting raw data visually for human pattern recognition and analysis. And why do you want to do that? Hundreds of thousands of correlations a day. You can't possibly process them all. You need further and additional insights into log data that's not coming from the detection systems and the rules-based algorithms. You want to detect activity beyond the traditional intrusion and event management. It's a human visual perception automatically recognizes unusual patterns and helps understand what's going on. We don't know what we're looking for. Writing a rule, for example, to detect a diagonal attack would be really hard and expensive. We need to get down to the underlying log data and attach to the case. It's not just enough to see a pattern in a chart, but you actually want to get the logs out of the system, out of the zillions of logs that are there, the set that you want to take the case investigation to further rigorously assess. And it must be proactive and real time, not lag. So you need to be able to go to these systems, grab the data, quickly paste it up. We would call this an analytic sandbox, where in an ad hoc fashion you can look at it, visually discover things, maybe bin in some new things, maybe run a quick descriptive model, try to figure out what's going on, then export results out. The value add, again, our client speaking, provides proactive and real-time analysis. It finds anomalies that traditional systems don't. You find new attacks that were designed to avoid the traditional signature-based detection systems, such as time stage attacks. And we'll look at one of these in a minute. Diagonal attacks, cluster attacks, octal jump attacks, embedded activity attacks. There's a whole set of things that go on that are trying to get around the systems, and they're very important to find. And then you also want to easily communicate and submit the results, case detail for further investigation. So let's look at one of these. I'm just going to click, and I'm going to run this in a web browser. So I'm loading in some log data, and I'm bringing it up. And this is a view on the left that's looking at. We're looking at a week's worth of data, and we're looking at the source IP address compared to the destination IP address, and the axis, the vertical axis, is how many events there were. So there's some things that stand out here. There are these vertical lines, which are normal, and this is when a whole variety of sources are coming to one destination address, typically a file server. Multiple people are going to the file server to access files or run an app or whatever they do on it. So these are pretty normal. Down here, there's one huge one. This would be a case of one source going to one destination and probably doing a bulk file transfer, a big one. So that might be something you'd want to look at. It's certainly a different pattern than everything else we're seeing here. There are some others in that range that are a little smaller. There's one here and one here that we might want to investigate as well. But what really jumps, let's call it the horizontal anomaly. There's this set of hits coming from, looks like basically one source IP address across a whole range of destination IP addresses. And it's a very unusual pattern. I mean, that's not the kind of thing you would normally expect to see. So let's explore it. So I can visually select it by just sweeping with the mouse and grab all of them. And now let's go to another page, event timing. And here we want to look at when are these hits from this horizontal anomaly actually occurring. So we've got them, this is time going from, looks like 2 a.m. on the 17th of, the 16th of August all the way up to the 24th. So it's a week's worth of data. And you can sort of see this one fires a bit in here. It fires twice, and it looks like it's on the 17th at 6 p.m. It bursts and goes quiet, bursts again, and it goes quiet until up here on the, looks like the 19th at 8 p.m. It bursts again, and it goes quiet. It comes back a few days later. That's what we call it a time stage attack. It's coming in bursts at different periods of time, and which is different. I mean, the gray here is all the other events going on in this period, and kind of some of them. This one that went in fairly consistently, then went quiet, and then came back a few times. Here's one that was bursting, when it's come on a lot more. So this is a great way to look at not just what's going to what and how much, but when it's actually occurring. The other thing that's apparent here for my horizontal anomaly threat is that when it fires, it's very intense. It dominates. So the red line here is the amount of hits coming from the threat, the potential threat I selected. The gray is everything else. I can see it dominates. It dominates. It dominates. It dominates. So that's a pattern that we are concerned about. So let's drill in on it. Get rid of everything else, and let's look at this first attack over here. So I select it. Let's go back to the first page. What's going on? Well, it looks like it's really a pretty intense probing because it's hitting multiple times across the whole range of destination addresses going to. This is one. This is a much higher number. So it's coming in, probing across a whole variety of servers, and it's a very intense probing. Then it comes back. What's it do when it comes back? Let's grab this one. So it comes back, and it's a fairly pervasive probing, but it's mostly one hit per server. So maybe it learned something the first time, and now it's coming back in a little different way and trying to get in. So it helps me understand what's going on here. And so at this point, if I'm thinking about this, there's some strong evidence here that something bad's going on. Now I probably want to close the loop a little bit with other context-sensitive data. For example, what is the source IP address? Where's it come from? Who owns it? Why might it be doing this? Are there factors that might be driving this timing of these bursts? Is there some reason they would go like this? What other contextual information might there be I could bring in to look at this? Now let's look at a few other things. I'm going to grab the entire threat and look at it in what's called a parabox view. So in fact, let's bring the rest of the data back to compare this potential threat in relationship to all of the data that I have for this period. So the red is my horizontal anomaly. The gray, again, is everything else. It's almost all of the high flag security events. It's like half of the attempt outcome. It goes through this one source IP address. It goes through a variety of source ports. Looks like it's very focused on the destination ports. And then it spans out from those, whatever, a couple of destination ports across this wide range of destination addresses. And we've learned that it came in very intense at the beginning, and then when it comes back, it probes fairly systematically. Now let's go back. In fact, let's show you. I can bring all the, if I'm looking at the entire thing, I can see the entire portfolio of everything that's going on, and I can slice it any way. But in this case, I want to explore this one anomaly. So just a quick point that these visualizations are powerful, and they can pivot a variety of ways. Let's drop in on just this event again. So it looks like it's coming out here through destination ports 139 and 445, only two. So I look up in my system, and 139 is net BIOS, and 445 is Active Directory screening. So this would look like it's really trying to access files across a bunch of machines through these two ports. So now I'm even more concerned about what this thing is. So let's look at some other details. So I just, in my analytics sandbox mode, I posted up some other tables with other factors that are in the data I have. And I can sort of see the Rockford DE. I can look at this additional stuff. I just pasted some stuff up. Different destination zone URIs, this Montana, Rockford, whatever these things are. Looked at some other of the fields in here. So this is the whole idea of visual discovery. I'm trying to see, are there some identifiable patterns in the makeup of what's happening in this horizontal anomaly compared to everything. And so I've got what I want. My event details lists all the logs for this. I can now export it out from my security visualization system, drop it down into Excel, and give this to case investigation with the description of what I've learned so far. And again, I did that in like 5 or 8 minutes. So I'm in Excel, and then I can do this whatever I want. This could have a whole bunch of the other fields that were in the SourceFire data that I started with. So that's the idea. And let's go a little bit further. And we want to run some predictive modeling against it. So I've visually explored it. I got some sense of what's going on. In a visualization tool like this, we can pop up a panel to create a new model. If I click on it, a modeling panel comes up. I call this the horizontal anomaly. It's from the SourceFire data set. I selected the horizontal anomaly, so it's going to model the characteristics of that against the rest of the activity in this period. I've got a whole bunch of potential explanatory factors, some of which we saw in the chart, some of which we didn't. I would take out the time because I know it's a time stage attack. I saw that. I'd probably take out the destination ports. We already know it's trying to hit through a couple of destination ports. We saw that visually. What else can I learn? When I run the model, let me just back up for a second. Before I run the model, I can set the training subset. This is a fairly small data set we have here, so we run against all of it. It's a huge data set. You might slide it back to get started with. You can set p-values. So there's a couple of modeling things you could set, but you can see from this interface, we have tried to make the modeling really easy for an analyst to use. You don't need to know stats. You don't need to have a statistics degree or anything. You just, if you have causal thinking and curiosity capabilities, you can use something like this. And then it comes back with an output that says, hey, we think we found some correlations, and here's a set of things that seem to describe the horizontal anomaly. And some of these we had not seen in the visual views, and we probably want to explore these further and put these down as factors for case investigation to consider. We also do create a score. You can sort of see the range score. There's a group of outliers, and most of it is not aligned towards this. In this world, obviously, since we're finding anomalies, the predictive part of this is probably less important than the descriptive. And analytical modeling like this can do both. In our view, is it completely complements interactive visual discovery. And in a security visualization tool, the two together help you get this kind of understanding. And going back to our client and how they would talk about this, they'd say the process for this is really key. A lot of people just throw a ton of logs at a tool, but often less data is better. In this case, we took the SourceFire data for a week because we thought there might be some suspicious events in there, and we found a couple. We found a bulk data transfer, maybe 2, 3, and we found this horizontal anomaly. And the best of breed, they start with the problem, anomaly, notable event, then they use the visualization to carve down the data to understand what's going on and to determine which logs need to be investigated further. Then they export those logs to case investigation. And if our clients were here, they'd say a tool like this is a question generator. It helps you ask the questions, try to figure out what else do I need to know. In this case, like what's the context for this? Let's go get some data for that. And if you had the data, we could load it in as an additional data source to the SourceFire and blend it and integrate it to help get the answer. It's not just answering the questions. It's trying to figure out what are the questions I need to ask, and then what can I learn about those questions, and what more can I do? So, as we summarize this, we see security visualization software as an ad hoc analytical sandbox. It's for security analysts to muck around in the data, to bin it, synthesize it, visually explore it, model against it to understand what's going on. And we put that in a desktop tool. Our primary tool is a Windows desktop, kind of like a super-powered Excel, to power the analysts to do this. I was running in a browser that we can deploy out, but the actual authoring, modeling, all that occurs in our world in this analytical desktop sandbox. You can push the results out over the web, and they're highly interactive. So the thing I was running in the demo, an analyst had set up and passed it to me to say, what else can you learn from this? And, quite a bit. So we'd say there's half a dozen parts to a security visualization tool like this. The ability to mash up unstructured data, combine log data from ArcSight, Logger, Splunk, and other SEM sources with existing data sources from within the company using data blending and in-memory capability. You got to be able to load in data. You got to be able to think through, hey, there's another data set here. Let me bring it in. I can key it together on a variety of things. I can key it on IP address, on time. It depends what's in the two tables, but there's a lot of ways we can do that. And again, we do it in a Windows desktop. Don't have to do a bunch of database stuff to do it. Correlate machine data with other structured data. Enables security analysts to correlate, analyze, and visualize machine data, which we saw before, with other structured data for advanced business analytics. So the concept is you can bring it in and bring in other contextual factors. Blend, synthesize, and structure data. Perform numeric, string, date calculations, conditional calculations within and across tables. We sort IP addresses. We can look for subnet inclusion. We can address timestamps to one time zone. This was suggested by one of our partners because a lot of these logs are coming in with a timestamp from different time zones, GMT, Eastern Standard Time, Pacific Standard Time, and you actually want them all in one time zone because you want to see the absolute time relative to an event. And they need to be time shifted. So we can bring in the independent time zones, don't have to change them in the databases. We can shift them here in the app. Visually explore, slice and dice, and export results. We kind of saw an example like that in the demo. Build and deploy descriptive and predictive models using no-coding analytics software modeling to determine common factors and various anomalies, and then create scores to flag future incidents. It's really important because that directly complements. So if there are 10 or 15 factors, most human beings can visually explore them. Well, the more analytically inclined human beings can visually explore that. But once you get past that, and a lot of this data is much wider than that, you can't. And that's where the modeling can come in to give you clues as to what matters more. And then securely access reports and analyses, so that part of visualization about pushing stuff out to management, which I kind of poo-pooed a few minutes ago, it actually is part of this. And yeah, you got to be able to distribute impact reports and dashboards for easy consumption in a web browser. So just as we close, we're a firm that's had a ton of experience in this space. As I said at the beginning, we've worked with a number of Fortune 100 clients, mid-sized firms, governments, government agencies, 2 of the large SEM vendors, and we've won awards in this space. And had just a breadth of experience. And I think what it really comes down to at the end is the context and the process of identifying potential problems and having the ability to go in and flexibly explore the data in a sandbox form to understand what really matters. And when you find what really matters, you want to take it to case investigation for forensic, just deeper dive in more context and figure out, is this something I really care about? Can I write a rule about it? What else should I do with it? So thank you for the time. We are open for questions. I think there's a chat box on the bottom. And if you put questions in, we'll answer them. We have some of our own will pop up in a minute as well. But I think this process and this human pattern recognition beyond the writing of rules and aggregations is really important. And all I know is that our clients, who are some major players in a variety of industries who have done this, have got a really good value add beyond and complemented the systems they put in place. Yeah, so one question would be coming in, the web-based versus the desktop versus hosting, which is the platform discussion. Yeah, so the thing is, so there's a bunch of discussions out there, and there's a variety of places software like this can run. We author and we provide an analytics sandbox on a desktop Windows PC. We allow you to push it out over a Windows server so it could be consumed in any kind of browser, iPad, tablet, or whatnot. And we can also run in a hosted environment If you don't want to run the server on site, we have a hosted environment, Amazon Web Services. We can run from there. I think, from our perspective, for people doing this kind of work, we strongly prefer the Windows desktop environment. Our authoring, our analytics is kind of like working in Excel, where our expressions, our linking is like writing macros in Excel, and our model is to empower analysts that way. And you've got direct access, and we fit large footprints of data. We compress heavily in efficient RAM footprints, so you're not going to be overloading your PC. But we find that freedom, that flexibility of just being able to run this thing, and ad hoc sandbox analytics is different than publishing BI reports or publishing set visualization structures off a warehouse or something. That's not what we're doing here. What we're doing here is empowering people to do this on their own. And we actually call this kind of killing the cycle of pain. So back to that page on the smaller businesses where you have trying to cross-rough stuff in Excel, and it's just hard. We can consume 10, 20, 50, 150 tables of data and link them and join them, create cross-table calculations, and just empower people to do pretty sophisticated analysis all on a Windows desktop without having to rely on IT or other people to prep, do stuff with the data. We just do it here. So we get this a lot, and I know there's this growing trend to put things in the cloud and all of that, but you put things in the cloud, there's advantages, especially for scorecards and general reports. For analytics, we like the power of the PC and the power of being able to be in control of what you're doing and just try things and experiment without burdening or like really doing anything to another system. If I answered that, it was a long answer. Here's another question. How easy is it to bring all the data together, and how much data can an advisor actually handle? Great question. So how much data can we handle? Let me do that first. We can handle, so it depends on how much RAM you have. I have in front of me a 16 gig Windows 10 laptop. I can run 80 million rows of data with 400 total fields, and maybe it's in 110 tables. We have client projects in other sectors that are that big. And on my laptop, I'll have sub-second response on an interaction. We usually preload the data. So there's another question of, generally in a case like that, we're going to pull the data at some point, and then we're then going to load off a compressed embedded file. My load time for something like that might be 30 to 45 seconds. We would say if you're going like hundreds of billions of rows or hundreds of millions of rows, of data, we probably want to talk about binning it, subsetting, cutting the time off. Usually in this world, we're seeing 20 million, 10 million, 30 million, 5 million rows of data. Usually it's fewer tables, fewer dimensions. We more probably are seeing 60, 70 dimensions, not 400 or 500. That'll run fine in a 4 or 8 gig footprint machine. And again, we compress heavily, and this data is generally more numeric and less string intensive than some of the other data sets we load, which could have comments and whatnot. Then how do we bring all the data together? Was the first part of the question. So in our app, we're loading relational tables from sources. We create projects. So if you picture Excel creates workbooks, we create projects. So you build something, somebody's loading this view, they're loading some tables, they're putting up some pages, they save it back as a project. That thing will then, it can be set to reopen and reload the data. And so it knows it goes to Oracle, goes in whatever, grabs these tables, goes to Vertica, goes in and grabs these tables, goes to, whatever, Splunk, goes in and grabs these tables. And then they stream into our in-memory pool. To us, they just look like the same table. We don't know that they came from different sources at that point after we've loaded them. And then in our world, you can write expressions to roll up tables. You can link the tables together, which is some of what we were seeing here. You can create calculations that go to one table and do something on bin something, do some conditional on something and copy it back to another table, all of that. And then we key the tables together if there's common keys in what we load. Otherwise, we often create synthetic keys. We can key on date. We can key on combinations of date and IP address. We can key on IP address. We can parse fields apart and create keys on subsets of them. So we do that all the time, and that's algorithms that you create in our world if they're not in the database. And if you're in the sandbox mode, that's often the case. There may not be keys for the data sets because you just acquired one, so you need to be creative about how to match it to the data you already have. But yeah, that's a lot of what we do. And another, this is not cybersecurity, but we just did some work in the healthcare field where we had a patient encounters, which was completely not linked to a donor database. And there was no keying. You had medical records in one and you had donor IDs in another. We were able to take the number, the digit number of the street address, find the major name in the address. So it was like North Beacon Street South. We take Beacon, drop the rest of it, pick up the zip code and the last name in both tables because they had addresses and last names. And we got like an 85% accuracy match by doing that. So the databases didn't have it. They should have it, and I'm sure they will in the future. But the analysts are trying to play around and see is there a correlation between people who do certain things in the hospital who are also donors, and we needed a way to key it. And it maybe took us a half a day to figure this out, try it a few ways, and then implement it. And we're loading, I don't know, it's like a pile of patient records, and we're loading a pile of donors. So it's a lot of data on two very separate tables coming from two very separate systems. So that was an indirect way of answering the question. Other questions? What's the skill set of the typical user? The person who's best with doing something like this is somebody who's inquisitive, curious, can see causality. I mean, you're trying to, in this world, spot things that look unique. And you saw in that 3D IP address with the size. I mean, we're using XY layout. We're using height and color to try to create patterns and things. And those are all variables that analysts can adjust. And you're trying to use those things, layout, size, shape, color, to find things that are unusual. And then when you spot the things that are unusual, you need to think about, okay, like, what else might be going on here? And that, that parabox where we saw the destination ports, maybe whoever set the thing up hadn't put that in. Well, you wanted to say, okay, why don't I stick destination port in here and see if that makes a difference? And hey, in that case, lo and behold, it did. So it's that ability to be inquisitive, to see things and want to explore them, to create hypotheses, refute them, continue with them. All of that is, and causality is the key skill sets. Here's another question. Would it be possible to get a perpetual license of Analyst X plus updates for further research? Sure. We could definitely do that, and I see a name, so we'll follow up after the webinar. But there's a couple of other points in there. Our software, we typically sell perpetual license or traditional model there, so you basically buy the software. We have updates, we're getting them out every 7 to 9 months. Obviously, the hosted thing is a subscription, but it's hard to imagine somebody in this space wanting to run that way. And our updates are, we had to release one back where it was focused on this market, where we added the IP subnet sorting, we added the date time transfer because of that issue where we're getting data where it was coming from different time zones and needed to be merged together. So this is a market that's important to us. We have great customers in it, great partners, and we're continuing to make updates to our products in general, but also for this market. Other questions? We're getting some good ones. Yeah, there's, I'm trying to just read through these, so give me a second here. Do you have any advice for somebody just getting started in this area. I'm running a smaller company. Well, I would say a couple of things. You need a correlation engine. I mean, it's really hard to do this. If you go back to let me go back a few in here. If I go back to here, and if you're literally working with these, the intrusion detection, firewall, virus scan, all this stuff as separate systems, and they're not connected, it's a lot harder. If you have a correlation engine in place, and there's a variety of these, and some of them are pretty pricey, some of them aren't. There's lower end correlation systems that even smaller mid-sized businesses can put in, which start aggregating the stuff all of these create into one common system and lets you start writing rules. And we would say probably that's probably the right first step. And then once you get that rolling, this is where we come in, because seeing these things helps you understand what needs to be set, what rules need to be written. So I guess that would be my advice. And then just remember the words of wisdom wherever they were back here. Be strategic and don't just dump your systems with all kinds of stuff. Be thoughtful. Use the anomaly notable event algorithms in the correlation engine to create subsets out of everything and then explore the subsets. Don't necessarily start looking at the entire environment. Carve down, be strategic. Use tools like this as question generators and exploration tools. So that'd be my advice. And I think that's the advice of our clients in specific and also in general. See, some of the questions here are more specific, and we'll follow up offline with them. We covered the topic pretty good. I'm going to wait another little bit. I'll wait another few seconds. If anybody's got a question, put them in now or forever hold your peace. And getting done a little bit early is never a bad thing. So we all appreciate that. Okay. I'm going to, do we have another question? I'm going to say there's more information on us on our website, advisorsolutions.com. This is my contact info. We do a ton of work in this area. We'd love to talk more. This webinar has been recorded, and we'll have it posted up on our website. There's a resources webinars page, and there's also a security and intrusion analysis part of our website. We'll have this thing up hopefully within the week. So thank you. So thank you for your time and attention, and have a great rest of the day.